Okay, let's just sketch our PV graph. That's always a good way to start. This is a constant pressure process, 1.00 atmospheres. Now, the volume was going from 50 centimeters cubed up to 100 centimeters cubed. And we were told that heat energy was added. Q was equal to 20.9 joules, and we were asked what's the change in internal energy equal to. Well, the easiest way to do this is we have the heat here, Q is equal to 20.9. We can work out the work as the area under this curve. So work is equal to minus the integral of P dot dV. It will be negative as it is expanding, so the gas is doing the work. So this is minus. The pressure is 1 atmosphere, so 1.01 times 10 to the 5 pascals. And the change in volume is from 50 to 100, so that's 50 centimeters cubed. So 50, and now 1 centimeter cubed is 1 litre. So we'd have to 1 milliliter, sorry. So we'd have to times it by 10 to the minus 3 if we wanted to get it into litres, and then into meters cubed we times it by 10 to the minus 3 again. So solving that on the calculator, we end up with minus 5.05 joules. Okay, so now we can just use our first law of thermodynamics, change in internal energy is Q plus W. So that's 20.9 minus 5.05, which gives us 15.9 joules of energy is added as internal energy. Okay, so that's the answer to part A. Part B said that N was equal to 2.0 times 10 to the minus 3 moles. And we were asked to find Cp. And we know that for a constant pressure process, which is what we have here, Q is equal to NCP delta T. Okay, so we're trying to find this. We know Q, we know how much heat was added, we're told up here. And so now what we need to do is work out the change in temperature. Now this is an ideal gas, so the change in temperature, we have PV is equal to nRT, constant, our pressure's constant, so our change in temperature is proportional to the change in volume. So the change in temperature will be the change in the volume times the pressure over nR. Substituting in, our pressure is 1.01 times 10 to the 5. Our change in volume is 50 times 10 to the minus 6 meters cubed. That's what we worked out down here. The number of moles is this should be 2.00. 2.00 times 10 to the minus 3 times R, 8.314. Solving that, we end up with 303.7. Okay, so now we've got everything. Cp is equal to Q over N delta T, which is 20.9 over 2.00 times 10 to the minus 3 times the change in temperature, 303.7. Solving that on the calculator, we end up with Cp is equal to 34.4, and the units are joules per mole per Kelvin. Okay, and finally, part C, we were asked for Cv. The easiest way to do this is to realise that Cv is equal to Cp minus R. So all we need to do is take off R from this, which is 8.314. 34.4 minus 8.314 gives us 26.1 joules per mole per Kelvin. So that's the answer to part C. So we've made a bit of a mess of that. Okay, and that's the end of this lecture.